the fundamentals of piping system. Okay, before going to that, in between the piping system, I want to know about your previous experience or previous study knowledge about energy sectors and oil and gas industry, crude oil processing, and after that I will deeply going into the piping system. Before that, I want to give some brief about that, what is energy sector is actually doing, what is the major role in the oil and gas industries, how the crude oil is extracted from the underground and the underwater levels and it's getting to the surface, then how we are processing the crude oil. These are all the major things we need to know about the oil and gas. I think someone's mic is on.
Participants, please unmute yourself. Sorry, mute yourself. So if you have any queries, you can unmute it at the end of the training.
Okay, thank you. So today's training content is start from the energy sector, then I will go deep into the oil and gas industry, then how the crude oil is extracting and it's going to be processed, then what is the difference between that refinery and the petrochemical plant, then we can go into the basis of piping engineering. Fine. Before going to the energy sector, I want to know, ma'am, all the participants are from mechanical background, am I right?
Yes, Ashwin, everyone is in the mechanical background.
Okay. So, participants, do you have any previous knowledge about piping engineering or about the oil and gas engineering? Because myself also, I am also mechanical engineer. While I am completed my degree, in that time I don't have enough knowledge about oil and gas sector because I only know about the automobile and other industries only. So I want to know that do you have any previous expertise in that or previous knowledge about energy sector or oil and gas industry related to the piping? You can just use the chat box if you have any previous idea about that, then we can go ahead here. Okay, fine. So in the P&ID, you have seen a lot of pipes over there, a lot of equipments over there, and a lot of valves and the functioning main process line, utility. Most of the major things which are all actually located in the site or the plant, the details are covered inside the P&ID. Okay. So basically these kind of drawings are used in energy sectors. Okay. So what is energy sector? First we need to know about that. So the companies or the industries which are producing and supplying the energy, those kind of companies are called as energy sector. Okay. In here, I fluids we are working in most for the oil and gas industries and the petrochemical plants and the as well as other power plants also we are using. We are doing the engine design and engineering services. Here you can see what is the major energy sector in the overall the world. So the major key role is played by oil and gas industry. They are the major suppliers to satisfy the demand of the whole world's energy need. Okay, so in the oil and gas industries, what are the main functions or the main operations are involved? So the initial activity is identification of resource, where it was actually got from the its surface or under the water. Then we need to exploration to getting drilled and getting some way to reach that fluid medium under the water or under the ground level. Then we need to develop the oil or gas reserves and then drilling, then production. Production means you are extracting the gas from the gas or the oil from the surface, from the underground to the surface level. For that operation, we need to do some special activities. So these are all the production activities. Then we need to, once you get the crude oil from the ground surface, then you have to refine that. Then once you refine, you will get the final product. The product should be marketed over there and it should be stored and transportation. So these all activities are need the huge supply of manpower, huge need of manpower as well as the equipment, asset and the area to satisfy the demand. Okay, so these kind of all the activities having its own facilities, equipments, and transport for the transportation of the pipelines. These are the major key player in the energy sector. So each and every word containing the large quantity of equipments and the manpower need. Okay, so these kind of activities are performed by the industries. Those kind of industries is coming under the energy sector, and if they are directly dealing with the crude oil or other natural resources, but in some time we need the support to extract that resource from the environment or from the ground level or the sea water level. We need some special equipment. That equipment manufacturers also coming under the energy sector. Okay, so that is what I have mentioned in the second point. The companies offering oil and gas equipment are also considered part of energy sector. Here you can see in the picture some refineries photos I have put, and as well as some thermal power plants and the wind farm. So these all are here. You can classify the renewable and non-renewable resources. So the wind farm also coming under that energy sectors. Then, so what are the types of energy resources? I think these are the basic things we have studied from our school education. Once again, I want to remind you all that things we can classify as two. One is non-renewable energy, the another one is renewable energy. So non-renewable energy, you have already, you all guys are already well known, and I have classified some of the examples of that resources: the petroleum products, the natural gas, gasoline, diesel, nuclear, coal. These are all the things. From the renewable energy, you can say the hydropower, biofuels such as ethanol. It is extracted from the grasses or other wastages, bio wastages. From the wastages, we can get extract the ethanol also. So it is also the renewable energy. Then the wind power, solar power, and hydroelectric. These are all the major classification of energy resources. Then, who are all coming under that energy sector? As I have already described you, once you identify the location of the resource, then we have to drill and doing some exploration activities. So that kind of activities are handled by some companies. Those companies are coming under energy sectors. Okay. Then once you extract the things from the underwater or the underground level, then it should be transported to another storage or nearby refining area. So for that, the transportations and storing purposes, we need pipeline and refining providers. Those companies are also coming under energy sector. Then the third one, the mining companies. Apart from oil and gas, you can know the coal is a best fuel in the last century. Okay, so the coal mining operations are handled by some companies. Those companies are also coming under energy sector. Then now these I think from the past 20 years, our nation and as well as the world organizations also trying to invest the huge investment to convert into the renewable energy. So the renewable energy also coming under the energy sector. For example, the wind power and solar power. Yeah. Now, our motto is I want to give the more detail about oil and gas industry among those energy sector companies. So, what is oil and gas industry? Okay, so basically we know the petrol and diesel. These are the common terminology we are daily in our daily life. We are using those kind of words. Okay, so where it is getting extracted or where it is getting from. So by it's a huge activity with the involvement of multiple resources. They are working day and night to extract the crude oil from the resources area. Okay, so this oil and gas industry is also called as petroleum industry, and the huge the process. The global process is exploration, extraction, refining, and transportation, and it will be marketing to the even all the consumers like industries or household or all the consumers will getting the petroleum products from the marketing team. Okay, so the largest volume of the product from the oil and gas industry, the largest volume of products were extracted is gasoline and fuel oil. So petroleum is extracted from the crude oil, and apart from that we are extracting hundreds of sub byproducts also from the crude oil. Those byproducts are the raw materials for many other chemical plants, for example the pharmaceuticals, fertilizer plants, pesticides. These are all prepared from the petroleum byproducts. So the petroleum byproducts are the feedstock for those other major fertilizer and pharmaceutical plants. Okay. Now, inside that oil and gas industry, I want to give the brief picture about three major components. The first major component is upstream, the second one is midstream, and the third one is downstream. Okay, so I want to give the clear picture about upstream. What is upstream in the oil and gas industry, and then what is midstream, and then what is downstream. Okay, here I have put some images over there. So the upstream activity is starting from the identification of crude resource or the gas resource from the underground level or the underwater level. That is the first case. So the first scenario is identification. These are all done by many researchers, and many companies are specifically doing these kind of jobs. The second one, once you identify the huge resource from the under level, means under the surface level, then you need to do some engineering activities to getting extracted. There are multiple, in nowadays multiple technology has introduced to extract the crude oil from the ground level. So I have put some beam pump. These are all the old technology. Right now also it's in the usage, but it is a old technology to extract the crude oil from the ground level. Okay, so the we need to choose which way is correct and more efficient to getting extract the crude oil. That's the second case. Then we need to do the drilling and providing the exploratory wells. So we need to drill something with the use of rigs, and the drilling will be happen. Then we need to install the operational, the pumps, motors, and the adjacent pipings. Everything we need to install over here. So this is the that case. So the identification, drilling, and the production installation of the production facilities, and the relative piping networks. These are all coming under upstream. Okay, so the major activity is recover and bring the crude oil and the natural gas to the surface from the underground level. So these major activities are coming under upstream. Which are all the companies performing these kind of activities? Those companies are called as upstream companies. The second one, midstream. So what is the second stage? After you are extracting the crude from the under level to surface level, you have already pumped the fluid to the ground level. Now we need to store that particular extracted crude oil. Then it should be pumped to the nearby refining unit, and the refined product should be transported to the consumers like manufacturers or the retail sales something. Then some of the fuels on the refined product, there are thousands of byproducts are there. Okay, once the excess quality of extracted byproduct, it should be the huge amount of extracted fluids will be stored, and again it will be distributed to for some of for the air fuel, some for the home usages, some for the industry usages, the major quantity for the vehicle utilities. So these are all the major role after you are extracting the crude oil. Okay, so except this refining part, once you extracted the crude oil from the ground level, it should be stored somewhere as a crude stage. Then it's pumped up to refinery for the refining process. This refining process is called as in the downstream, okay? But from the ground level to storage, from the storage to up to the refining area, these pipeline transportation networks is called as midstream. Okay, once the product is getting refined, the downstream of the byproducts is going to the manufacturer end as well as the storage end, and for the daily usage for the consumers. These transportation, these pipeline transportation and the storing facilities is also called, also coming under the midstream. Okay, so here I have clearly put that the midstream sector involves the transportation by pipeline. The transportation may be happen by the pipeline or by the rail or barge and the oil tanker or trucks, anywhere. What will be the medium? But the transportation of crude oil from one place to another. Those kind of activities are performed by some companies, right? So those companies are called as midstream companies. And again, if once you refine the petroleum products, the pipeline and other transport systems can be used to move the crude oil byproducts to the different consumers. Those piping networks also coming under the midstream activity. Now, the third one, it's a downstream. So the downstream is exactly once you get the crude oil from the surface level, you store it somewhere, and it's transported to multiple mediums to getting to the for the refining stage. So the pipelines are routed till the refinery. Oh, so the number of equipments in the refinery, what will be the major process? The crude oil processing will be happen. Okay, so the crude oil processing, I will deeply explain to you before that. The crude oil processing is happened in refineries. Okay, so the refinery have multiple set of equipments, multiple plants are there. Each plant have multiple set of equipments and the piping networks. You can see one typical image of refinery I have put over there. You can see the complexity of piping and the structures and the equipments, you can see over there. And once the refined product is from the crude oil, we are going to refine and we are going to produce large number of petroleum byproducts. Those byproducts, these activities, so that refining activity is happened in the refineries and petrochemical plants. So these are all coming under downstream. Once you getting the byproduct from the refinery, in some cases based on the location, it will be directly routed to the nearby consumers. Like if we having the refinery in Gujarat area, the surround at 200 to 300 kilometers, we can make the direct transportation of that fluid, means of the petroleum products. So those areas also coming under. If you are actually says those transportation part is coming under the midstream. In some exceptional cases, the downstream companies will perform the midstream activities also. These are all the cases. It's based on the location and the availability of consumers. So the major byproducts I have listed over there: petrol, kerosene, jet fuel, diesel oil, heating oil, and lubricants, waxes, asphalt, natural gas, LPG, and naphtha. These are under thousands of, yeah. Here I have seen hundreds of petrochemicals also, the byproduct of the refineries. So now I have cleared about what is upstream, what is midstream, and what is downstream in the oil and gas industries. Now, what is crude oil? So first, crude oil is extracted from underground. Everything is right. So how it is looking like? It's a black liquid. In some cases, some brownish black also there. So the crude oil is a black liquid found in geological formations. Okay, so it is a fossil fuel. So the terminology fossil is the formation of the fuel or from the dead organisms that are buried under intense heat and pressure. So it's getting from the underground, and some cases in the, under the seawater level also. Okay, so The crude oil is the black liquid. It's getting from the geological formations. Fine. Now, there are three primary qualities for the crude oil to define the category because there are the different quality of crude oils available over the world origin. Okay, because from the North America also producing the oils, the South America's oils also there, the Gulf countries also producing gas, even in India also we have some exploration wells. So how we can categorize the crude oil quality? Okay, so to define the quality there are three primary parameters are there. The first one is weight of the crude oil, the second one is sweetness of the crude oil, the third one is tan count. Okay, so based on these primary qualities we can categorize the crude oil. First we can see about weight. What is a weight in the crude oil? Fine. So based on the weight we can categorize into two. It's heavy and light crude oil. Okay, so what is heavy crude oil and what is light crude oil? Fine. In the heavy crude oil have the higher density. Okay, so it will be evaporate slowly. So the extraction of the byproduct from the heavy crude oil is little difficult and more complex process. So the major heavy products are like asphalt. You know, asphalt for the road paving and everything, we are using the asphalt, right? So the heavy oil majorly producing the asphalt, some kind of gas extraction everything will be there, but the major byproduct will be the asphalt from the heavy oil. Okay, in the light oil. Okay, what is light oil? It's a less density oil. uh, from that light oil we can easily extract greater percentage of gasoline and diesel than compared to the heavy oil, because like from the light oil only we can easily extract the byproducts, useful byproducts as a fuel. In the light oil you can the density is less, so the evaporation quality also high. We can getting extract the more number of gas volume also from the light oil. Even in the 95 percentage of fuel in from the light oil we can directly convert 95 percentage of light oil into the direct fuels. Only 5 percentage will be the other petrochemical byproduct, but from the heavy oil it can't be, it based on the quality. Okay, so for determining these things we need some scales. So American Petroleum Institute, to measure the density of oil they have scaled on they have estimated on scale that is called API gravity. So the standard unit to measure the oil weight is API gravity. Once the resource is find out in the surface level, means underground level, first the particular team will do some crude oil sampling. So after drilling they do some crude oil sampling. Based on that crude oil sampling, these are all the three things: the API gravity, the sweetness, and the tan count will be in the data sheet. They will doing multiple samples and get the details of that particular crude. Then it will be categorized. It will be what kind of crude oil is this? Is this one a heavier or lighter? It's a sweeter or sour, or it's a less acidic or high acidic? Those kind of details will be determined after the extraction. So in the API gravity, so what is the formula they have used to determine the oil's weight? So the formula is 141.5 divided by specific gravity of the crude minus 131.5. If you are putting in that values over here, you will get the values around from 35 to 80. In that range of you can get the value. Okay, if the value of APA gravity is 39.7 and lesser than that, it will be considered as heavier oil. Okay, if it is more than 70, means 65 to 70, in that range, you can consider that oil is a lighter oil. In between that 40 to 50, it's based on the, we can consider as a minimum medium level of medium dense crude oils. second part is weight we have already seen. So according to the weight, there is two major sectors. One is the heavy and the light. Now we are going to see about sweetness of crude oil. Okay. Oh, what is sweetness or the sour? Based on the sulfur content uh, incorporated, I means participated in the particular crude oil. Based on the quantity of sulfur inside the crude oil, that will consider, that will make that particular fluid as a sour or sweet. The percentage of sulfur content in the crude oil is less than 1%, then it will be considered as sweet oil. Okay. If it is 1% or more than that, in the range of 1 to 2%, then it will be considered as high sulfur level. So it is considered as a sour crude. So then, if it is sour, then what we need to do? Then, once a crude is identified as the sour gas, then means sour oil, then it will be stored with more protective storage vessels till the crude is going into the refineries. Okay, first it's getting into the refinery. The first thing will be the process of removal of sulfur content in the crude oil. So if you can consider it, if the sulfur level is less than 1%, then we can directly use that crude oil for the further processing. If the sulfur content is higher than 1 to 2%, then in that time we need to first reduce the sulfur level from the crude oil. So some additional equipments and the additional manufacturing processes also needed while you converting the crude oil from the sour to sweet. So these are the cost. These equipments and the process will take some additional cost. So it will also decide the crude oil refining prices in the commercial and economical also. Okay. The third one. The third quality is tan count. What is tan? Okay. Total acid number. The tan stands for that total acid number. So it will decide the extracted crude is more corrosive or not. This is the major thing. So if it is more corrosive, then we need to give some additional protection to the equipment and the pipelines and wherever the crude is transferred. Those kind of additional protection and the precautions are needed in the metallurgical selection. Okay. So but how to measure the tan count? So here I have seen put some examples to you. If the count 0.01 milligram of potassium hydroxide per gram and 3 milligram of potassium hydroxide per gram. Okay. So if the value is 0.01 milligram, then it will be very low corrosive. If it is in the range of above 1 to 3, then it will be requires more protective metallurgy selection because the acid count is high, so it will easily corrode at the pipelines or the equipments wherever the crude oil is transferred. Okay. So what is this unit is giving the information to us? So milligram of potassium hydroxide per gram. So we need to, once you identify the crude oil is a acid, acidic nature, then we need to neutralize that. Okay. To neutralize that crude oil, we need to add some potassium hydroxide with that crude oil. Okay. For 1 gram of crude oil, the requirement to neutralize that crude oil, we need to add the potassium hydroxide, right? If you are adding 0.01 milligram of potassium hydroxide with the crude oil, then if it is getting neutralized, so that will be the tan number of it. Okay. If you record 0.05 gram, then it will be that is the tan number of that. So in that similar way, if you need 3 milligram of potassium hydroxide to neutralize the crude oil, then it will be the higher tan count. It will be more corrosive in nature. So these are the three major qualities to determine the crude oil standard. So then once now we have the clear picture about the oil and gas industry. The second one, the crude oil. Then
Sir,
hello,
sir,
sorry.
uh, sir, can you explain again about the TAN count, sir?
Sure, sure. I will do that. Okay.
Okay,
Uh,
thank you, sir.
yeah. The tan count. The crude oil is in somehow from the ground level, the surface level, we are extracting the crude oil. In that time, if you are feeling, we are doing some sampling test in the crude oil. In that time, they came to know the pH level of the crude oil. If it is in the acidic nature, it determines if the crude is acidic nature. Then yeah, somehow we need to pump it out that a particular crude oil to the nearest storage area or the refinery area. Okay, so we need some pipelines, we need some storage vessels in till the crude oil is going to reach the refinery. If you are using for each and equipment and the pipeline, we need to determine the design life. How many years of this pipeline is going to serving us? How many years of the storage tanks will be going to serving us? So we need to calculate that things. So how we can able to calculate means how much thickness of the particular equipment is needed for the designing or for the operation of next 25 years. So it's a one hidden component to determine the wall thickness is the fluid characteristics also. Okay, if the fluid is acidic nature, it will be reacted to the wall surface of the pipeline or the wall surface of the storage vessels, and it getting reacted, the thickness will be automatically reduced. Okay, to for that particular reduction, to avoid those reduction, what we do is trying to dissolve that, trying to neutralize the acidic nature in the crude oil. Okay, so to neutralize that we are using some external agents. So that external agent here we are using potassium hydroxide, so that is KOH. Okay, so the amount of KOH required to neutralize the crude oil is called as tan count. Okay, if 3 milligram of potassium hydroxide is enough to neutralize 1 gram of crude, then the tan count will be 3 milligram KOH per gram. Okay, if it is less than that, you require 2 milligram or 1 milligram of potassium hydroxide to neutralize that particular crude oil. The neutralization means I trying to reduce the acidic level inside the crude nature, the crude characteristics. Are you clear now, or I want to explain again more?
Okay, sir, clear. Thank you so much.
Okay. Then the third one is crude oil processing. Once you transfer the crude from the surface level, the storage areas, the pipelines, then it getting into the refinery area. Okay, so in the refinery area, what are the operations majorly is done? It's not the exact number of operations based on the crude characteristics. The operations may be differ, but these are all the basic things you can see in the each and every refineries. Okay, so once the crude oil is getting from the storage area, it's routed to the boiler. Once it's heated, then it's going to the vacuum distillation column or the atmospheric distillation columns. Based on the boiling point of the fluid, the multiple byproducts are extracted in the different boiling levels. Okay, if it is the 20 degrees, you can see the gas is extracted, and in the 40 degree, about around 40 to 70 degree, the naphtha, and around 120 the gasoline. These are the different boiling points. Based on the boiling points, the byproducts are getting extracted from the distillation column. Okay, so the carbon count for each byproduct is listed over here in the image. You can see the 4 for the gas, the carbon count is 4. For the naphtha, the carbon count is 8. For the gasoline, the carbon count is 8. For the kerosene, it's 12. For the diesel is 16. For the lubricating oils, it's 36. The heavy gas oil, it's 44, and some residuals, it may be 80. Okay, so fine. So the distillation, the refinery, in the refinery you can see the distillation column will be there. The major operation of distillation is to separate the crude oil as two major fluids. It's one is higher, means heavy fuels, and another one is lighter fuels. The separation process of heavy and lighter fuels is called as distillations. Okay, so I have already explained to you, if the oil is lighter, you can extract more number of gasoline and as well as diesel or other byproducts as a direct fuel if the oil is in the lighter way. If it is in the heavier way, then you cannot easily extract those things from over there. So first in the distillation column, the crude oil is getting separated as heavy and lighter fuels. That operation is called as distillation. Okay, then the cracking. The heavy oil is getting extracted. It's got separated from the crude oil. Now what we need to do is, by use of some catalyst, the heavy oil will be diverted into large number of lighter fluids. Okay, so we are trying to extract the lighter fluids from the heavy fuel. Okay, that process is called as cracking. Then the reforming. Here you can see the carbon count of naphtha and gasoline is same, 8. So the carbon content is same, but the molecular structure of naphtha is little complex. Okay, so but the industrial gasoline having some kind of chemical structure to compare to the, it's different from the naphtha. So we are trying to make the same kind of because we are majorly in the need of gasoline extraction, so trying to convert the naphtha into the gasoline. That process is called as reforming. So the structural rearrangement, that kind of activities. There are more chemical reactions and chemical formulas over there, but I'm not from the background of that chemical engineering. So these are the major overview. What is exactly happened in that distillations, means in the refineries. So those details I want to share with you. That's why I have put these slides over there. And these kind of reforming activity from the naphtha to the gasoline reforming is called as reforming. It will be performed to multiple reformers. Okay. Then the blending. Sorry. Hello.
When you can proceed, someone joined, I guess.
Okay. Okay. Fine. So the third, fourth one is blending. Okay. So what is the blending process? Uh, for the each fluid in the gasoline, while you are visiting the petrol stations, you can see the number of the different categories of gasolines over there. It's classified based on the octane numbers. 91, 93, 95. There are different number of octane numbers. Okay, the quality is based on the ignitions, based on the ignition. Okay, uh, to attain that particular number of octane number, we need some blending activity. Those kind of activities also happened in the refinery stage. So those activities called as blending. It will be make the gasoline to suitable for the engine specifications. Okay. Then the treating. Once the gasoline is extracted from the lighter fuel, then it have some sulfur content in it. So we need to remove that. If we are not removing the sulfur content, it will be harmful for the environment after it's getting combusted into the engine. So the harmful gases may be released from the extraction and the fuels. Okay, so we need to try to minimize the level of sulfur in the gasoline. Those kind of treatment activities also planned happen in the refinery stage. Okay, these are all the major overview of crude oil processing. If you want to learn more about that, you can just try to Google it. You will get the exact idea what the refinery is exactly doing nowadays in the crude oil processing. More number of technologies over there. Yeah. Then the difference between the refinery and the petrochemical plant. In the refinery, we are getting the input as the crude oil. So the feedstock of the refinery is crude oil. Then it's getting refined and reforming and cracking. The multiple operations will be happen inside the refinery, and we are majorly developing the byproducts. Okay, so that byproducts maybe the gasoline, naphtha, the byproducts means the diesel, air fuel means jet fuel, asphalt. There are multiple amount of byproducts. Hundreds of byproducts will be extracted from the refineries. Okay, so the major difference between the refinery and the petrochemical plant is the feedstock of refinery is crude oil, and it's developing the and its byproduct is the petrochemical byproducts. Lot of gasoline, fuel kind of also the some other chemical by substances also extracted from the refineries. In the petrochemical plant, what we are performing, getting the byproduct of the refinery. What is the outcome of the refinery? We are getting that raw material as a input feedstock. So that chemical petrochemical petroleum byproducts is getting into the multiple types of products. For example, the polymer production means plastic productions, and the dyes and the detergents and fertilizers. There are many number of products are developed by using the petroleum byproducts. Okay, so the major byproducts are categorized into the two way. One is olefins and the aromatics. So here you can see that olefins and the aromatics, the carbon structure is in the symmetrical way. The carbon and the hydrogen arrangements are in the symmetrical way, then it is called as olefins. If it is in the benzene kind of ring, then it's called as aromatics. It's a basic idea about that what is olefins and aromatics. Okay, now we can see what are all the olefins we are getting. Some of the olefins, I'm not detailing in all the things. I want to share some major substances, major petroleum byproducts is ethylene, propylene and butadiene. These are all the major substances we are getting from the refinery as a feedstock to prepare the plastics. Okay, so this is the major olefins we are getting from the petroleum byproduct. Then from the aromatic side, some aromatic substances also extracted from the refinery, like benzene, toluene and xylene. So these are all the raw materials for making dyes, hair dyes, and as well as the synthetic detergents also. Oh, and the sulfur, that sulfur content is a major raw material for the fertilizer units. So these are all the things. So the refinery, the processing of crude oil is happened in the refinery, and multiple n number of petroleum byproducts are developed in the refinery. That byproducts are developing into the multiple other products. So for that component, for that operation, petrochemical plant is helpful for us. Okay. Fine. So these are all the things. First of all, I want to convey with you, because you had some overview of what is oil and gas, what is energy sector, what is crude oil, how we are going to treat over there. So all the details we need to know about that. Then only we can find out how the piping engineer is going to support us for the extraction of the petroleum products. Okay. So what is piping here? So the piping is a system to use to convey the fluids. It may be the liquid or gas anywhere from one location to the another location. Okay, so this is the basic idea of the pipes, right? This is the major things everyone knows. Then why these engineering requires a lot of engineering manpowers, engineers to develop this piping engineering. So the major mode of the piping design is to get the efficient transportation method. Okay, anyone can build the pipe, anyone can give the pipe. That Piping is not only about the 100% engineering. It needs some imagination power also. How we can route efficient way. Okay, how we can save the piping materials, how we can reduce the project cost. So these are all the things are coming under the piping engineer while you are working as a engineer in the piping discipline. Okay, so the piping means it's just a conveying medium to get one fluid from one location to the another location in the efficient way. Okay, so what is the role of piping engineer? We can categorize in two major activities. The one activity is the location of the equipment in the layout, okay, in the plant. The second one is the interconnection between the equipments by using the piping. So these are all the major two things. One is equipment layout, and then the second one is piping design. Okay. So why these two things are important for one piping engineer? Okay. I think yesterday you've gone through the P&ID. In that P&ID you can get the details about the equipment. For example, if you have one storage vessel and two pumps, and it is connected to that piping is converted to the next another one storage tanks or another one separator or another one separator columns. Somewhere it is going. Okay, so our major component is one storage vessel, and adjacent we need to pump that fluid, so we are providing two centrifugal pumps over there. Okay, then these piping flow, one piping network is required to reach the destination. Okay, so where we need to send that particular fluid. So these are the things we can getting, these details we are getting from the P&ID. So the tank capacity, what is the capacity of the tank, what is the dia of the tank, what is the height of the tank, what are the instruments placed inside the tanks and outside the tanks, how many nozzles and flange connections are needed, what is the size of that particular nozzle. These are all the details you can getting extracted from the P&ID. These details is available in the P&ID. And the piping, you can consider the pipes. So what is the dia of the pipe? Uh, how many valves is going to place over there? What is the material of the pipe? What is the flange rating is required? How many drain connections are needed? How many vent connections are needed? How many instruments are going to placed over there? What kind of measurements we are going to take? If it is a level, if it is a pressure, if it is a flow. So these are all the details you can get from the P&ID. Then the third one for the pipe rotating equipments like pumps also. What is the flow rate of the pump? What is the differential pressure of the pump? What is the head level? Everything, every details you can get from the P&ID. But in the real time, if I'm providing some surface or land to you, and I'm trying to convey, this is my requirement, and I have one tank with this capacity. I having pumps of two numbers of pump in this capacity, and I want to put some piping arrangements. Then it should be going over the destination. This is my ideology. This ideology is provided in the P&ID, but in the real case, if you are going to install or commissioning the same in the plant, you will be having more difficulties over there, because you have to consider a lot of other considerations. So you have to lot of other parameters in your mind, because if you are providing one tank in the surface of the ground level, the soil resistivity and everything taken into the part. Okay, the soil is withstand, the soil should withstand the tank's weight in the operating condition, because the tank are in the huge sizes, right? It's going to store some quantum of liquid. The weight of the overall tank is going act in the surface of the soil. So we need to estimate the foundation, how much, what kind of foundation is required, in which depth the foundation will be going, what is the soil conditions over there, what is the bearing capacity over there. These are the details we need to know. And then once you furnish the location of the storage tank and the pump, it should be near to that. Otherwise, unnecessarily, you are providing more number of or much quantity of piping over there from the to the interconnection between the tanks and the pump. And And one more thing, you should meet the process requirement as well. Okay, if you are placing the pump and the storage tanks in the wrong locations, you may not get the results whatever exactly exact. For example, the fluid should be come to the pump in the positive manner. Okay, in the positive pressure. If the positive pressure is not maintained over there, then you will not get the proper suction, and the discharge may not be happen as per their estimated value. So a lot of systematic and other factors are also in the piping discipline to consider while you're laying the pipes. Okay, so these are the roles to follow for those all the activities or the for all the considerations. We have some certain rules over there. Okay, because we are handling with the flammable gas, we are handling with the harmful gases and the harmful fluids. Okay, if you are handling in the wrong way, it will cause to the major accidents and the injuries. So the things, the major things we are going to do is in the safe operation manner. So it's also meet the design level of the equipment and the piping network. These are all the for to maintaining these all the things. We have some certain number of codes, standards over there. How to develop the piping, how to develop the piping network, what we need to do, what we don't do. That means what we don't need to do, what are the certain rules we should follow while doing the piping design. All the details are already researched by some teams, and it was recorded as a codes and standards. Okay, so once you're getting into the piping engineering field, you should know about the what the code says, what the standard says, how the practice of the repeated things will make you a good piping engineer. Because if you are doing the things in the multiple times, you will familiarize with the things, and you can easily make the efficient piping, and as well as the economical pipe laying also you can be able to do them. Okay, so these are all the roles of the piping engineer. Then where the piping engineer will be required. Okay, so most of the piping engineers you can see the oil and gas industries and the petrochemical industries. Okay, and apart from that, in the chemical plants also you need the piping support. Power plants also need the piping support. Steel manufacturing units also need the piping support. Where we are handling with the water and paramedical water and the steam. So for there also the piping engineer support will be required. For the buildings as well. So the fire water routing, the foam network routing, for all the things we need one piping engineer support. So the design of piping will be common where the fluids is handled by the pipes. Okay. So as I have already told you, the major activities in piping is equipment and development of equipment layout as well as the piping design. Okay, so the major considerations we need to take into the mind is one is the access. So the equipment should be accessed by everyone. The second one is the removal space. If you want if you want to remove things, means the removal space means if you want to take the equipment for the maintenance, or if you want to replace something in the equipment, the removal space also should be over there. Otherwise, if you are locating all the equipments near to near, and if it is placed in the congested way, you cannot able to, the equipments will be in the huge size, so you cannot able to place the cranes over there. You have to give some ways to for the movement of crane for the fire engines and the major other vehicles, to getting that equipment in the uh, accessible way. Okay, then the cleaning area, the yearly cleaning or the 2 years of only made based on the process requirement and the project requirement. The cleaning will be scheduled. For the cleaning activities we need to give some provisions over there. Then for the storage and space of storage space for the spare parts also. If you want to store some spare parts, if you want to store some periodic maintenance parts if needed, that storage space also we need to give, and as well as the handling facilities, means the handling for the operation. If you want to operate some walls over there, you need to give the space over there. Okay, if you're providing all the piping and all the equipment in the congested way, the man cannot go enter into the facility and cannot operate the means the requirements. So these are the major things. One is access, the second one is removal space, the third one is the cleaning area, then the storage space and the handling facilities. These are all the major considerations while you are preparing the equipment layout. Okay, then what is the piping design? So the piping, okay, so in the piping design is a critical component in the engineering projects, right? So it's not a 100% of engineering activity, as I have already told. It's 50% of engineering and 50% of imaginary skills of the particular piping designer. So you can make the efficient piping, but it should meet the process conditions as well as the safety as well as the design life of the piping systems. Okay, so how we are going to do the piping design, I will explain to you in the next classes or the next training schedules. How we need to know about from the scratch where the piping design will be start and how it is going, how it is getting processed, and what will be the final outcome of the piping design. So these are all the things I will explain to you in the further classes. As of now, we need to know what are the major activities was performed by the piping engineer. One is equipment layout, the another one is the piping design. Okay, to prepare the equipment layout, what are the major things, major inputs we record from the other discipline or other teams? Okay, so to prepare the equipment layout, first of all we need the process flow diagram. Okay, so from the process flow diagram you will get the major detail of the equipments, what are the major equipments over there, and what are the major pipeline or piping, uh, what is the size of that piping. Okay, these details you can came to know the process flow diagram. Then the P&ID. P&ID is piping and instrumentation diagram. Here you will get all the equipment details in detail, as well as the major process piping and utilities and other process pipings also, and as well as the number of valves over there, the size of the valves, the number of instruments over there, number of connections over there, number of drain points, number of vent points, all the details you can get from the P&ID. Okay, then the project design basis. In that project design basis, the facility background, where we are going to exactly place these equipments. So the surface level, the weather conditions, the soil conditions, all the details are available in the project design basis. Okay, then the geographic location, the topographic details. Geographic and topography is the major things while you are considering for the equipment layout, because based on the soil condition only and the waterways only, you can determine where we need to place the equipment in the inside the plant. Okay, then some local standards and guidelines. It depends on the company. For example, if you're working for the Qatar, the Qatar regulations and the standards will be different. If you're working for another any other company, like if you're working for any Muscat or Oman, in there the local standards and guidelines will be different. Okay, so we should follow what are the local standards and guidelines saying about the equipment locations. Okay, then the plant layout specification. Specification means it's only developed by the individual companies. Each and every company having some set of rules while determining the equipment spacing. That specification should be followed. Then layout and space availability. If we are handling in the existing plants, if we are going to introduce one new equipment in the existing facility, in that time you need to determine the existing space availability where we can locate these particular equipment, how we are going to access, how we are going to install that equipment. So all the things we need to study. So the space availability in the existing facility is the major constraint. Okay. Then we need to know the equipment sizes. What is the exact size of the equipment? These details we can get it from the we can got from the vendors or the manufacturers, okay, who are going to manufacture that particular equipment. We need to getting the GA drawing from the general arrangement drawing from the manufacturer. Then only we determine what is the exact size of the equipment. Okay. Then the climate and weather condition, the wind direction, also the major part while you are placing the equipment layout. Then the road access ways and paving. To install the equipment you need the nearby road access and the paving to make some man accessible areas. For that we need the paving access also. Okay. Then the drain outlet, if it is existing facility or the new facility, the entire plant drainage will be going into the treatment plant. Okay. So the nearby drain outlets are need to be identified while you are executing the equipment layout. Then the nearby buildings, for example control rooms or any other laboratories are inside the plant, it should be taken into the control. Because if we are handling with the flammable fluids, first of all we need to perform some study uh, based on the inventory of the fluid, flammable gas inside the storage vessel. If it is getting fired or if it is getting blasted, how much radius will be affected because of that accident. Okay. So the buildings or humans are should be avoid from the means major hazardous area. So that hazardous area classification is also the major requirement we are developing the equipment layouts. Okay. So I think I have covered all the topics which I have prepared for you on today. Okay. So if you have any doubts on these sections, you can ask me. Tomorrow I will going to teach about what is codes and standards, and how the piping design will be performed from the initial stage to the outcome, and what kind of calculations we are going to perform over there, and what are the materials, how we are choose the materials for the piping design. So these are the topics I'm going to teach you on tomorrow classes.